Okay, the next part of the question. It's part F. It's the cooling temperature curve. And we got the T1 around here. We got the T2 somewhere around here. So T1, it's a eutectic composition. So how's the graph's gonna look like? First off, the graph is gonna look like normal graph. That's not normal. It's gonna just go like this, and like this. We got temperature, time. So it's gonna start from, yeah, it's gonna start from a temperature and it reaches eutectic temperature. Basically, that's it. Tectic line. And the other one, T2 composition, radium higher selenium. And that one's a little bit tricky. The temperature time graph. It starts from a particular temperature. Then it goes like this. Then for some time, with the eutectic temperature and goes directly down. All liquid. SE and RA solid equally. Why does the temperature stay same? Because during the process of changing like from liquid to solid, uh, there is a release in temperature. Thus, the during that process where selenium and radium converge to solid while having a little bit liquid, the temperature is gonna stay same. That's why at the eutectic line the temperature stays same. We could see that same pattern here where it's also eutectic. It's all liquid. What's this? Radium. Uh, starts to crystallize at this point. Radium fully solid plus selenium little bit liquid, not fully, and then both solid. Here also both solid after the eutectic line. I forgot the term. There was a term for this one. It's an isotherm isothermal situation, but I don't remember exactly what it was. Yeah, I think that this is basically it. Temperature and time. So in the case of T1, here we can see the T1 passes through the eutectic point. So it's a eutectic composition. Now, what is a eutectic composition? It is a composition with the lowest melting temperature in the entire alloy system. So I don't know what composition it's gonna be here. I mean, it looks like it's a 70-30 type of composition, but when you get the eutectic composition, that's when the alloy having the lowest melting point. The metals as their own, they have really high melting point, as you can see both here and here. They both have higher, I don't know, did you see that? But they both have higher melting point up there. But when they become alloy, it's different. But in the case of a specific alloy called eutectic composition, that alloy will be having the lowest melting point. And that's why, and that temperature and that composition is, oh, what the fuck happened? Yeah, that composition is eutectic composition, and the temperature time graph looks like this for eutectic composition. Starts with all being liquid, then it reaches the eutectic line. It's a specific temperature where both selenium and radion in the specific composition equally or simultaneously converts to solid while also being having a little bit liquid form. But at the end, when it reaches here, with the sudden drop in temperature, it's gonna be fully solid. The same goes here, but first, not the same for the T2 composition. First starts at liquid, then radion starts to crystallize slowly while Se still liquid. No, I forgot the spelling for still. God damn it. Oh, still STIL. Come on. Just a minute. STILO liquid. And when they reach the eutectic line, radion is almost crystallized, that is solid, but selenium is starting to crystallize, but I don't exactly know if they've fully I don't think they fully crystallize at this point, but when you go past when you go temperature below the eutectic temperature, it's gonna just both gonna go solid. Yeah, I think that's it for temperature curve. If there's any changes I should be making, please let me know.